Hello there. We're about to just review very quickly parallels and perpendiculars. This is Regents Review session number 1 preview video. We're going to talk about parallel and perpendicular today. So these are the types of questions that you're going to see pertaining to parallel and perpendicular. I would suggest that you write down everything that's on this, but certainly it's your choice. The first question that you might see is which equation represents a line that is perpendicular to the line represented. It's imperative that you know that perpendicular means negative reciprocal, opposite signs flip. In other words, when we want to create a 90-degree angle, we want to take the slope and we want to find the negative, which actually means opposite sign. I know that's confusing to some people. When it says negative, it just means the opposite sign. So if the slope starts as positive, then perpendicular would be negative. Reciprocal means flip. So you flip the actual fraction that you get. So in this particular case, you start out with 2x minus y equals 7. You get y alone, which I think we're all pretty good at. We're getting y alone nicely, and I want to just ignore that little line there for a minute. We want to get y alone. So we get y alone, and we end up with 2x minus 7. In this case, the slope is 2, so the perpendicular, since this is positive, then this is going to be negative, and the flip of positive 2 is negative 1 over 2. So the only choice available is choice 1. Pause the video if you need to. In the meantime, the second equation that you'll get that's similar but a little bit more involved would be write an equation that is perpendicular, again there's the perpendicular, to the line but passes through a specific point. In this case, the point 8, negative 2. So if we're starting out with this same equation, and we get y by itself, we already knew that y equals 2x minus 1. We also already knew that the perpendicular slope was negative 1/2. So therefore, our answer has to start out with y equals negative 1/2 x. The difficult part about this is trying to find the value of the y-intercept, or the b value. So you use the formula, the y equals mx plus b. You sub in what you know. This is an x, this is a y. You sub in what you know, and you find the value of b. So the y value is negative 2. We know the slope has to be negative 1/2. We know a y value of x. Negative 1/2 times 8 is negative 4. Add 4 to both sides. You then get the y-intercept, which leads you to your final answer. The third type of question that's asked with parallel and perpendicular pertains to, again, the same type of thing, but this time it says parallel. Parallel means same slope. So again, we're going to start out with the original equation that we started out with, the 2x minus y equals 7. And this time we want to find a line that is parallel to that line, but passes through 8, negative 2. So again, if it's parallel lines have the same slope. So the parallel slope is 2. Using y equals mx plus b, you sub in again. The y value is negative 2. The x value this time is 8, and the slope is positive 2 because we want the parallel slope. Same exact process to find the value of b, and then you can substitute in to get your final answer. As Mr. Carpenter says, we're going to switch gears now, grind those gears, and we're going to talk about parallel lines cut by a transversal. These two lines, L and M, are parallel because they never intersect, which means they have the same slope. Line N right here is called the transversal. It's really, really important that you understand that parallel lines create some very special angles. Corresponding angles are equal angles. 1 and 5 correspond because they're in the same position. So they're equal, which means if angle 1 is 30, then angle 5 is 30. 2 and 6, just like I have here, are corresponding. 4 and 8 and 3 and 7. All those angles are equal angles. The other fairly popular are alternate interior angles. Alternate interior angles means that the angles are on opposite sides of the transversal and inside the two parallel lines. So these are alternate interior angles. 3 equals 6 and 4 equals 5. Those are alternate interior. Related but not the same, and that should say alternate exterior. Let's go ahead and fix that right now. This should say alternate exterior angles. Alternate exterior angles are also equal. Related, alternate means on the opposite sides of the transversal, but exterior means outside those parallel lines. So angle 1 and angle 8 are alternate exterior, and they are equal. And angle 2 and angle 7 are alternate exterior, and they are also equal. And then we have same side interior, which are not as popular to ask, but sometimes they are asked. When you have the same side of the transversal and inside those two parallel lines, these are called same side interior, and they add to 180. So for example, the example that I used, angle 5 was 30, which means angle 3 would be 150. And then you have linear pairs. Linear pairs are adjacent angles, angles next to each other. They share the same vertex, and they create a line. So angle 1 and angle 2 are a linear pair because they create a straight line, and they also add to 180. Angle 2 and 4 create a linear pair. They add to 180. 5 and 6, 5 and 7. Any two angles that create a line is called a linear pair. The last example really doesn't have anything to do with parallel and perpendicular necessarily, although it could sometimes, but it does have to do with partitioning a line. So if we have the coordinates of the endpoints of a segment, so if this is AB right here, A is -6, -5, and B is 4, 0, they're asking us to place a point on this segment that divides the segment into a ratio of 2 to 3. Now, in this particular case, this problem did have a scrap graph given to you. But I highly recommend that if a scrap graph is not given to you, you use the scrap graph at the end of the test, when you get the test, draw this picture that we're going to draw, and then draw a sketch of what you drew in where the test question actually is. Because on the exam, we cannot grade that scrap graph. So the first thing that you're going to do is you're going to graph the points. Now I'm going to be drawing with my arrow, so bear with me. It's not going to be very neat. This is A. A is -6, -5, and this is B, 4, 0. And the first thing after you graph those points is you're going to want to find the slope. You find the slope by counting rise over run. So rise 5, run 10. And the slope is 5 over 10, which simplifies to 1/2. When you find the slope, then you can take and you can just follow that slope to create the segment. So rise 1, run 2. Rise 1, run 2. And you can see these points that I'm making. Rise 1, run 2. And rise 1, run 2. And you can see that we've now created this segment. What you should also see is this segment is divided into 5 parts. Here's 1, 2, 3, 4, and 5. 5 parts. A ratio of 2 to 3 means that there are 2 parts and another 3 parts to give us 5 parts, and X is the size of the part. The question is asking us to divide this into a ratio of 2 to 3. So we have 2 parts right here, and we have 3 parts right here. And so therefore the P is going to be that point right there, which is the point -2, -3. This work is sufficient enough for you to show as long as you have a sketch of this. Have a great day.